So this video is going to go through the 2022 B1 question in higher level. It tells us the image on the right shows the Hooker sculpture in Eyre Square, Galway. The geometry of the design comprises a series of planar surfaces. Figure B1 shows the plan and elevation of three intersecting planar surfaces. The horizontal and vertical coordinates for points A, B, C, D, E and F are given. Partial coordinates for the point G are also given. The edges DB and FG are parallel. So you can see there you're given the coordinates and the elevation and plan. Part A then asks you to draw the given elevation and plan of the intersecting planes ABC, ABD and EFG. Part B, determine the dihedral angle between the planes ABC and ABD. So basically, what true angle can you see if you look between the two planes? Part C, then draw the elevation and plan of a horizontal line on the surface EFG and project an auxiliary elevation which will show an edge view of the plane EFG. Indicate the angle of inclination of the plane EFG to the horizontal plane. So there, that's important. After you've worked it out, you have to show what the angle is. So you have to write down a physical number for it. And then part D, locate the position of a point P on the plane EFG, which is a distance of 40 mm from the horizontal plane and 68 mm from the vertical plane. Determine and indicate the true length of FP. So once again, that's important. After you've figured out where the point is, you have to actually measure it then as well. So find out the true length of it and give that as a physical number. So in terms of positioning this on a page, you're given all your coordinates there. And for this question here, I'm going to be positioning it close to the top left. The reason for that is, when I read through part B, determine the dihedral angle between the planes ABC and ABD, I want to find what's common between the two. So you can see there, AB and AB. So I'm looking at the angle that this line is between these two planes. So there and there. That's the common line. So I want to work out what is the angle when I look perpendicular to that line when I see it as a point. So the first thing I want to do is work out the true length of that line. Because if you imagine like a pencil here, if that's the true length of the pencil and I want to see it as a point view, I look in perpendicular and you'll see it as a point view, for example, there. So in order to see a true length, we have to look in perpendicular to one of our views. So for example, our plan. If I look in perpendicular to AB there, I'll get an auxiliary view out here. That'll give me the true length of AB along with the rest of the points of the plane. And then somewhere out here, then I'll be drawing a second auxiliary view where I see that true length of the line of intersection as a point. So I can see nothing is going to be going above or to the left of this question so far. Everything's going to be going on this side of the page. For part C then, you're asked to draw the elevation and plan of a horizontal line on the surface EFG and then include the true angle the plane makes. If I took a horizontal line there and take it down, I'm going to be taking an auxiliary view out here somewhere as well again. So you can see all the work is going to be on this side of the page. And the last part then, locating the position of a point P, which is a distance of 40 mm from the horizontal plane and 68 from the vertical plane. Once again, all that work is going to be going on in this area of the page. So by planning ahead, I can see that I don't need anything to the left, anything above. Everything's going to be going slightly below and to the right of the question. So I can safely say that I'm going to use this part of the page to get my question set up. So I'm not going to measure, for example, 160 mm from here across. I don't want the question going into the middle of the page and then having not enough space to my right. So what I'm going to do is I'm going to pick my 160 mm point somewhere up here, and then I'm going to measure from there each time to get each point. So for example, if I picked this point here as my starting point as 160, I'll only go 20 mm more to give me 180. I'll go 40 mm to get 200, etc. So that's the best way of actually laying it out. So my coordinates there, my highest height is going to be 105 mm for point D. So for this question here, I might go down maybe about 120. and have that as my XY line. And I can maybe start just there. I won't say that's my 0 coordinate, I'm going to say that that's going to be where my 160 starts then. So for 160 then for A, it's going to be up 40 and then down 70. So remembering once again, that's our X coordinate, our Y coordinate and our Z. So it's over, up and down. So if I go over 160 and then I go up 40, there's point A there in elevation, and then in plan I go down 70. Then for B it's going to be 180, so I've already started at 160, so I'm just going to add 20 on there, so there's 180, and it's going to be up 80 and down 35. And for C it's 200, so I can go another 20 there. And C is up 0, so C is going to be there, and then it's going to be down 115. Then for D it's 225, so I add another 25 onto that. And it's going to be up 105 and down 10. And for E it's 245, so add another 20 onto that. And it's going to be 0 again, so I'll just put 245 there. E is there, and then it's down 95. Then F is 190 across, so I'm back to 160. Add 30 onto that. And I go up 40 and down 75. And then for F it's 260. Sorry, for G then it is, so I should have F there, not E. And then for G it's 260, and then you can see there, I don't know what these coordinates are yet, I'm going to have to work those out. So after 245 I can just add 15 on to give me 260, and I'll just leave it as a line there, I don't know what the coordinates are. So now what I have to do is join all of my points together to form my planes. So the planes are ABC, then ABD, and then EFG. So I only have E and F so far there. So that's my elevation and plan completed so far. So the last thing then to do is just Drawing heavy or plain so far? Right, so that is part A there for now complete. We don't know where point G is yet, so we have to work that out. Next thing then we have, for point G, forgot. We can see in the question just noticed there that F and G are parallel to B and D. We already have the line B and D. So you just use sliding set squares from BD, taking our line like that. So you can see there, they're both parallel. And we're told point G is over 260. So where a cross over there is going to give me point G. So we can actually draw in our plane there, and also in our, I'm just trying to change the focus a bit there, and keep it like that now, that should be a bit better. And we're also, we can see that B and D and F and G are parallel in plan. So do the same thing again below. We can line up B and D and then go from F, and where a cross is over, where G is there, gives us point G as well. So that line there is parallel to that one there. So that's now part A complete. Part B then, determine the dihedral angle between ABC and ABD. So the common thing between them is AB there, AB there. So the first thing I'm going to do is I'm going to go perpendicular to AB. So we line it up there, and we're going to work out the true length of AB and then take the rest of our points as well. So we're looking at ABC and ABD. There's our x1 and our y1 there. And I'll just move the camera down a bit so you can see a bit more there. Now, so as always we go two views back. So one view back would be into our plan, two views back would be into our elevation. So the height of A there, follow it down, follow it out. There's our point A. Point B then, follow it down and follow it out. Then you have point C is on the ground, so we follow C down and out. There's point C there. and then we have excuse me, point D then. That height there, follow it down and follow it out. So then we connect them together. So we have ABC. Connecting like that there, and then you have ABD. So there you have then your true length of your line of intersection, your LOI. So there's AB. We want to see AB as a point view, so we're going to look in perpendicular to that there. So we line up AB, extend AB out, D and C, and then we have our x2, y2. Once again, two views back, one view here, two views into our plan. So A is that distance there, follow it down, follow it out, and then B you can see is the same distance there, and you follow it down, follow it out, the exact same point. So A and B, we see them as a point view. Then we have C and D. C is that distance there, follow it out, and then D is this distance here, follow it down, follow it out. And then the angle we're going to get between the two is going to be that angle there. And that there completes part B, determine the dihedral angle between the two. Part C then, if we look at the question again there, it tells us draw the elevation and plan of a horizontal line on the surface EFG and project an auxiliary elevation which will show an edge view of the plane EFG. Then indicate the angle of inclination of the plane EFG to the horizontal plane. So we have to show the actual angle then as a result. So what we're basically doing is, if you imagine surface EFG, their elevation and plan, if we take it as that set square, they want us to draw a horizontal line, say, across it. Say that was your horizontal line there. When you have a line parallel to the XY line in one view, it's going to appear as a true length in the other view. If we look perpendicular to the true length of something, we see a point view of it. If we see a point view of that pencil there, that then automatically creates an edge view of that plane. So you imagine we see all three sides as one line, with the pencil being a point view on that line. So that's how we're going to solve this part here to get the edge view. So they're kind of giving you a hint by telling you to draw a horizontal line. So for this horizontal line, I can take it excuse me, it tells you take it from, doesn't tell you where to take it from. I'm going to take it from F because I already have that point there on the plane. Saves me finding another one. It hits surface EG at 1. If I take that down, see where 1 hits EG, it hits it at that point there. Remember, a line parallel to the XY line is going to be a true length in the opposite view, the plan. That's a true length of that line there. And remember, if we look perpendicular to a true length, we see a point view. That's what we want to do. So if I look perpendicular to that, based on auxiliary view out here, I'll be able to see that line as a point view, and then as a result I'll be able to see EFG as a line. That's going to be giving us our edge view. So all I need to take down is E and G then there, and then go perpendicular to that there. So there's my x1, y1 again. Remember, 2 views back, 1 view, 2 views. So I'm going to take my heights from my elevation. So E is already on the ground. There's E there. F and 1 are going to be the same height. So there's F, same height as 1. Follow them out. So you can see there, F and 1. And then G is going to be this height here. Follow it down, follow it out, and they should line up. Next thing I have then is to determine it. So you can see there this angle. I need to work that angle out. So I need to use my protractor for that. So I can see there it's going to work out to be 55 degrees. So 55 degrees there for the angle that that plane makes to the horizontal plane. So that there is part C now complete. Last part then is going to be part D. Locate the position of a point P on the plane EFG, which is a distance of 40 millimeters from the horizontal plane and 68 millimeters from the vertical plane. So the first thing I'm told is there's going to be a point on that plane somewhere. It's going to be 40 mil up from the horizontal plane. So I can take a line up 40 mil here first, which is what I already have. So it's going to be on that line along there, F and 1, because F was up 40 mil already. So it's somewhere along that. I'm told then as well it's going to be 68 mil away from the vertical plane. So basically if I measure down 68 mil there, it's going to be somewhere along this line here. I need to figure out where it's going to stop. If you remember, we created an edge view in part C, an edge view of that plane. That's our horizontal plane there. So remember, our distance for our horizontal plane is 40 mil. If I also measure 40 mil up there, I can see where that 40 mil height hits my edge view. It hits it at this point here. That's 40 mil up as well. What I can do is take it back then to where it hits my 68 mil line. Let's make sure I line it up there. Taking it back and I cross over my 68 mil line at that point there. That gives me point P in my plan. I can take it up there, and there's the elevation view of point P. It tells me then determine and indicate the true length of FP then. measure the distance from F to P here. It works out that it's going to be 43 mil roughly. So I'll put down 43 mil for that distance there. And that then completes part D there.